This week, we talk with Pawan Shankar from Sysdig, and in place of a new segment, we'll share even more interviews from Black Hat. So stay tuned for Application Security Weekly.
This is a Security Weekly production. False positives suck. With so many mobile apps to test, how much time will you waste on false positives? Eliminate them today with NowSecure. Only NowSecure automates static, dynamic, and interactive testing on real Android and iOS devices. Now you get speed, accuracy, and efficiency for DevOps, plus the broadest coverage of security, compliance, and privacy issues. Why waste time on false positives? Visit securityweekly.com/NowSecure to learn how to scale your mobile AppSec testing with NowSecure. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW.
Welcome to Application Security Weekly. This is episode 74, recorded August 26, 2019. I'm your host, Mike Shima, and I'm here with Matt Alderman.
Happy Monday.
Happy Monday, Matt. And I think we have a familiar voice we haven't heard in a while. Mr. John Kinsella is over here as well.
I report I'm still alive.
This is good. We thought we might have lost you in Vegas. We have exciting news about the Security Weekly webcast program. We are now partnered with ISC² as an official CPE provider. If you attend any of our webcasts, you will be receiving 1 CPE credit per webcast. Register for one of our upcoming webcasts with Zane Lackey of Signal Sciences, Ian McShane of Endgame, or Stephen Smith and Jeff Broucher of Logarithm, or all three, by going to securityweekly.com/webcasts. If you have missed any of our previously recorded webcasts, you can find our on-demand library at securityweekly.com/on-demand. So many of the big East Coast cybersecurity trade shows take place in crowded cities like Boston and New York, where parking is a nightmare and will cost you an arm and a leg. However, this year's Compass Cybersecurity Symposium is being held at Twin River Casino in Lincoln, Rhode Island, just 15 minutes outside of Providence. The venue has plenty of free and easy parking. Speakers include social engineering expert Chris Hadnagy and Security Weekly podcast founder Paul Asadorian. Use the discount code SW2019 to save $20 on registration. Security Weekly will be at Hacker Halted in Atlanta, Georgia this October 10th through 11th. EC Council is offering our listeners a $100 discount to attend the 2-day conference. Use discount code HH19SW when you register, or go to securityweekly.com/hackerhalted and register there. Make sure you check out the keynote, Paul Asadorian, and Mr. Jeff Mann's talk as well. Pawan Shankar has over 8 years of experience in enterprise networking and security. Previously, he worked for Cisco as an SE and a PM working with large enterprises on data center cloud networking and security solutions. He also spent time at Dome9, acquired by Checkpoint, leading their security and compliance product marketing efforts. He is now a senior PMM at Sysdig, focusing on their container security product, Sysdig Secure. Pawan holds a BS in electrical engineering from UCLA and an MBA from UC Berkeley Haas. Hi, Pawan. Thanks for joining us today.
Hey, thank you so much for having me.
It's great to have you here. In fact, we talked with Loris, I think, back in April on episode 56. And when we talked about that, in that show, we talked about monitoring configurations for cloud security, cloud services, containers, the importance of visibility. But there's more than just configurations to pay attention to. So let's dive in to some strategies that a DevOps team can choose to build up this kind of visibility. And I think
Absolutely.
one of those things is this Sysdig Secure. So let's start off with what that is, or perhaps even more so, why that is.
Yeah, absolutely. So let me just share my screen, and we can go through a couple slides. And would love this discussion to be around what we're doing, around container security in more detail. Can you guys all see my screen?
Sure.
Yep.
Perfect. Just to give some background on Sysdig, as you mentioned, Loris was on the show a couple of months ago. And for those of you that might not know, Loris was also the co-creator of Watershark. So very much from the roots of packet inspection, that was how Sysdig was designed and really built as a product. Building on that open source, on those roots, we've been very heavily involved in the CNCF. We've donated Falco, which is our runtime security project, last October, and it's gained a lot of momentum in the open source community as a way to do runtime detection for containers. About 6 months ago, we had about 1.5 million pulls on GitHub, and now it's anywhere from 6 to 7 million. So really, that base has been growing, and a lot of community-driven rules have been published to Falco. We are focused on the enterprise, with a lot of funding from top ventures, and to be successful in this space, we're strongly partnered with the ecosystem players such as Kubernetes, the cloud providers, AWS, Google, IBM, OpenShift, and so on. So the thing that you mentioned, as to what we're seeing in this space and the challenges, I think there's a lot of euphoria around Kubernetes, simply because it just makes it much easier to develop applications, and having them either on any location, on-prem, in the cloud, wherever you see fit. But the challenge that we're seeing, that's a little bit of the day two challenges, are really around the operations. And really, this is magnified because there's a visibility and a security gap. When you are deploying these containers and microservices in Kubernetes environments, and this becomes a sort of a black hole where you can't really defend what you can't see. Right? So this becomes a security problem at the end of the day when you lack visibility. And what you're seeing, are some examples of this in the past year and a half. Right? So back in February of 2018, there was a cryptojacking incident at Tesla, which was a result of Kubernetes dashboard being exposed, and they were able to access an S3 bucket, and access some telemetry data. In March, there was a query done by a security researcher on Shodan that found about 20,000 etcd credentials exposed. Right? And this is essentially the brains of your Kubernetes master node, which, if you have access to this, you can do anything. Right? You have the keys to the kingdom, if you will. And there were some other exposures as well over the last year. Weight Watchers had a Kubernetes dashboard vulnerability, and there were a lot more this year, really around some of the vulnerabilities in Kubernetes itself, the runc binary takeover, a denial of service vulnerability in Kubernetes. As these things keep popping up, it brings to light the problem where not having enough knowledge and understanding of how to implement the right security controls is a key blocker in enabling successful migration of cloud-native applications.
Yeah, I think to jump in real quick, that's that idea of the lack of knowledge and building visibility is pretty important. That seems pretty key, because it's also not just, well, I guess it's both tools, but also people that need to pay attention to this. But I think one of the underlying themes that we can get into as well is that you might have visibility in your legacy systems, in your data center, but that kind of visibility doesn't translate into a cloud native solution. And you mentioned too, Falco, that's that open source part of the CNCF. So what does it look like, or what does it mean to improve our knowledge as well as our visibility when we're bringing these tools into the cloud?
Yeah, absolutely. That's a great question. And, we're seeing customers using legacy tools as a way to address this problem, right? And that's usually because of this concept of what we call IT inertia, right? People don't want to change too much. They want to use what they already have, what they paid for, and say, okay, let me just reuse this for this cloud native world, and I'm hoping everything works out. But that's fairly a false assumption, because there's so many challenges with these legacy tools. So number one is they lack fundamental visibility into the container and cloud native activity. Right? You mentioned some of these existing tools, such as we have perimeter-based security tools such as firewalls, IPS, IDS that serve a function, but expecting them to address some of these security challenges is definitely a long wish. You really need defense in depth and an ability to have something that's more focused on the container itself. Right? There's the concept of containers being ephemeral, and not having enough visibility and not having enough context into what that container is doing will ultimately result in this visibility gap. And the other challenges as well is these tools are not built with a DevOps mindset, right? Because they were built 25 plus years ago and are not tightly coupled with CI/CD pipelines, scanning your registries, and so on. So there are challenges inherent, which requires you to think differently about what a container security and a cloud native security solution looks like.
Pawan, real fast, because one of the things I saw that was interesting is I was in the space with John, is that you had some people that were taking some of these new open source products like Falco or Cilium, for example, right? Kind of another approach to this. And they were taking these newer components, but they were doing like traditional stuff with them. It was like counterintuitive. You take this really cool open source project like Falco, and then you would spin up a privileged container, and then you would shove all the traffic through it so you could do standard like traffic analysis like an IDS, IPS. And you're like, wait a minute, you're like completely defeating the purpose of what these new tools are trying to do.
Exactly. Right. So there's a retrofitting concept which doesn't necessarily make sense in the container world, and you really need to think about security as more for containers as an end-to-end container lifecycle security. Right. So are you ensuring you're scanning your images before you even push them to production? That's a critical step, right? We talk about this shift left model a lot, and that's really the first, premise of making sure you're starting security early in the pipe process, right? That's sometimes a lot of times that's a process issue that I feel. Are your dev teams and DevOps teams really talking to those security teams? You see dev and ops coming together, but there's still a wall between the security and these two teams, which end up resulting in a lack of collaboration and a lack of how do you implement the right security policies, right? Because developers don't want to push images that are going to be slowed down by their security teams as archaic controls, but security teams are also concerned with the impact of just having all these images built from these open source packages. So that's one area where these two teams need to come together, and the right tooling can help with that process. But extending that, right, you have to also think about compliance, thinking about runtime security and forensics. It's not just one functionality of scanning or bringing retro, legacy tools, but it's really about thinking, how do you make sure that you're securing the entire container lifecycle?
Yep.
And then one of the challenges that we're seeing is, a lot of these specific container security tools today are, they were really built from the perspective of scanning your images and just configuration scanning, making sure those images are free of vulnerabilities. That was it, right? That was kind of the main premise. But as customers start to deploy these containers at scale and are using technologies like Kubernetes, they're starting to realize that a lot of those old world problems still persist in this world as well, but it's just a different mindset and tooling that is required to address them, right? So what I mean by that is runtime becomes very important at this stage, because a lot of things can happen, and the problems are exacerbated because containers can come and go in a matter of minutes or hours. But if someone has access to that data, it's very hard to do forensics, right, and actual troubleshooting. So this all ends up requiring low-level data and a visibility into both the telemetry data, the orchestrated metadata, as well as just the security events that are happening to stitch it together to really give you a better way to do day two operations, right? So this visibility into both security and performance is critical to successful and reliable operations for these containers at scale.
Yeah, your approach is unique because the way I think of Sysdig is it kind of started on the performance side of the house with containers
Correct.
first. Falco was an open source product. And then you realize that once I had the performance data, I could add security to it. Kind of what Splunk did a little bit in the log management side, IT logs into security logs. And I haven't seen many of the application performance monitoring tools yet start to move into the same kind of space, even though there might be an opportunity. But I
Yeah.
always knew that container security companies could move from the security data into other performance data because there's an overlap of some of that data that kind of makes sense to really build a much more holistic security and performance platform.
Exactly. And that's kind of where we feel, we've leveraged our core competencies, starting off as a deep troubleshooting and monitoring platform that was able to stitch together, the low-level data with the service level, Kubernetes level knowledge, container, cloud knowledge, and pull it together. But then we started realizing that, hey, these are data is data at the end of the day, right? Whether you're using it for security or improving your security operations, it doesn't matter. And a lot of times, when you think about it, a monitoring metric is usually your first indicator of compromise, right? If there's a certain denial of service attack that's happening, you see a spike in your CPU utilization in a specific pod somewhere, that might be an indicator that these two elements or data points are correlated, right? So having that ability to get that performance visibility and leverage it for security best practices and use cases is sort of our ethos, right, in terms of being a security and monitoring company.
Yeah, I think that's really interesting too, because especially with Falco, rather than just say security, you can actually map that into something like the MITRE attack framework, and you can get
Correct.
even more granular to be able to say, well, rather than just one big broad term of security, like what are the tools and techniques attackers use? And how much visibility into those do we have? And I think Falco actually has a pretty good coverage across many of the major components of attack framework. So I'm kind of curious if you'd talk about that a little bit more.
Yeah, absolutely. So Falco, as you mentioned, the open source runtime detection engine, and what we've done, this is coming from a lot of our customers to say, one of our large financials that have asked, can you map these container security runtime rules, Falco rules, to the MITRE attack framework? So we actually did an exhaustive list of going through each of the rules and tagging it with the different frameworks that are relevant to container security. So you have things like lateral movement, exfiltration, persistence, and each of these Falco rules now are mapped to those frameworks so that a traditional security ops team that is used to those kinds of security constructs and baselines can immediately understand what are they applying on their container environments. And there's a blog that's out there as well, a Sysdig blog that we've written about these Falco rules that are mapped with a nice table, so you can easily understand the context of Falco rules when they map to the MITRE attack framework.
That's cool.
So I want to shift gears and talk a little bit about what we've done in our latest launch. And talking a lot about security now. We've done a recent product launch this month, actually, August 5th. It was a Secure 2.4 release. And really the focus of this release is really building on the things we've talked about, right? Why is runtime important? And the impact of that in organizations and enterprise environments. The big focus from a feature standpoint that we've released is really two key things, right? One is this concept of profiling your containers, where we sit and learn about the behavior of that container that's running, right? Whether it's what is the network traffic that's going through that container, what are the processes that are spawned, what are the files that it's touching, and so on, to build whitelist model basically of that container. And this helps security teams because as you're managing at scale, right, it's harder to implement manual rules, and by the ability for us to do this automatically, drastically reduces the time it takes for them to create these policies. And the other one you mentioned on MITRE, it's interesting because all of these rules are now in Sysdig Secure, and you can easily tag, and apply these rules that are community or customer driven, and get the benefit of that within the product. Rules such as MITRE for file integrity monitoring are some new ones, and cryptojacking is another one that are all embedded now in the runtime security of Sysdig Secure. We've also enhanced some on the scanning side, which is again a big portion, but where we're starting to see that take off is, as you're scanning, customers want to understand the reporting, the alerting, of their vulnerabilities in a way that's streamlined and meets every level, right? But when a CISO or a management team is looking at it, they want to understand the risk posture, but then your response teams need to understand which images have certain vulnerabilities, how are they going to go fix it, so on. So this is something that we've released as well on the vulnerability side that I'm excited to talk about.
Pawan, does that mean now integration, when you identify a vulnerability back into some of those developer tools, is part of that alerting? Is that kind of where that enhancement is?
Yeah, absolutely. So, we initially had the capability to scan your images in your pipeline, right? Pre-deployment. So if you have Jenkins or CI, Concourse, any of those tools, you were able to leverage Sysdig Secure policy to say, okay, don't deploy this image into production if it doesn't meet your different security and compliance or governance policies, and also scan your registries. But the reason for the runtime is really that you may do a really amazing job of making sure you're secure when you're deploying those images, but new vulnerabilities might come out, right? This is where you need to have that runtime awareness and continuous reporting of any new CVEs that might affect your images. And that's really where we've built all of these functionalities to help with better reporting, auditing, and compliance use cases for your vulnerabilities.
Hey, Pawan. This looks great, and our listeners probably like hearing about the features here. It might be sort of handy for folks is walk through what does day in life of a container look like from, when someone actually checks in code. How does Sysdig actually handle that? How are you, what does that look like? Sort of step us through what that looks like.
Yeah, absolutely. I can actually show you that in the product itself. So let's take a look live for this. So let me just jump in. So talking about day in the life, where you would start with really, as you're on your journey of securing and monitoring these containers, you would start with making sure your images are being deployed securely, right? So we have these out-of-the-box policies. You can think about these as sort of guardrails for your images. You have these default ones that are built for different compliance use cases, but also ones that you can just customize for your own unique requirements. You can say and check for things like, is a Docker file exposing SSH, for example? If it is, stop the build. Is there a package that's running, or an image that's running with either OS or non-OS packages with a high severity CVE that's affecting that image and has a fix available? If that's the case, you may want to stop that image from being deployed. We can also check for things like licenses, are you running as root, or even just DevOps best practices, right? You can check for things like size of image. Is it greater than 2 gigs? Not only is this a cluttered image, but also just a larger attack surface. So this one single console gives you the ability to define your security, compliance, and just best practices and apply them into your Jenkins pipeline. So if you're running Jenkins or any other CI tool, you can leverage these and actually make sure those builds that are being deployed are actually adhering to these requirements. Next up is the runtime piece. Now you have scanned those images, but what happens at runtime, right? And this is from the life of a developer or an application owner, right? And what we're displaying is showing you all the images that are running in your environment across your different, Kubernetes deployments and namespaces, right? So in this case, the namespace is an application. I can get a holistic view, but if I'm an application owner and I only care about my specific application, like let's say this example voting app, I can click that and get a risk posture of just my image associated with that with the application. And it's an easy way to understand, if there's images failing, why are they failing? Give me some, results on my policies that I've run, what vulnerabilities exist, and I can quickly understand this and see, all the vulnerabilities associated with this image, sort them, and do all sorts of operations very easily through this UI. And the last part, this is the new release on the reporting that we talked about just a moment ago, is our ability to give you really flexible ways to query your data that we're collecting, right? And this is both static data. So if you have images running in any, if non-running images in your registry, you can just put in your registry repo tag information and actually get a list of all those images and CVEs. And similarly, you can do that for runtime. So this is the part that we talked about, is you may have new CVs that are coming up. And if that happens, you need to know and be aware of which packages are affected, what's the image name, which cluster is it part of, which namespace is it deployed in, all of that information we bring to light. And you can interact with this data now. You can start saying, things like, show me all my images with the specific new CV that's affecting my images. So a great way for you to interact with this data and quickly see, what's being affected.
That leads us also to that there's that other end of that life cycle when you mentioned about forensics. So there's a lot of difficulty because systems are so ephemeral. They go up, they come down by design. I mean, that's what they're intended to do.
Exactly.
But so how can we get better visibility from that perspective into these types of container environments?
Absolutely. So all of this that we've talked about is really around hardening your images from a vulnerability standpoint. But what happens at runtime? And that's very imperative because this sets the stage for the right security response that you can implement. So we do things like profiling your containers that we talked about, where we build automatic and learn profiles about each container that's running based on learning about network traffic, processes, system calls. This allows us to give us an idea of what a policy should look like for this container after a period of time of learning about what's going on within that container. After that, we can create policies that are very easy. So if you go to runtime policies here, you can see these are all the different policies that are implemented for detection of different environments or different violations in your environment. So you can say things like, did someone launch a suspicious network tool in the container? Right? And I can quickly see this and actually scope it to a specific part of my environment to say, okay, if this happens in this specific namespace, PCI namespace, for example, if I care about that, I can easily do this very quickly with this scoping capability, apply the rules from and then take certain actions where I can say, stop the container if this happens, so remediation action, and take a capture file, which is the forensics piece. And as you build these policies, when you go into policy events, you can really see when these incidents happen, how they were triggered, and get more information about it. And this is the real crux of doing forensics when it comes to containers, right? We give you this ability to see all of your events that have happened and actually understand, okay, if this terminal shell in a container happened, which application was it part of? So as an app owner or a cluster operator, I can see, okay, this is in this specific namespace. And now I can hand it over to my CERT teams who can do more incident response. And they can say, okay, if this terminal shell in the container happened, what did they do? Like, what commands did they run? And that's the first question that comes up. So you can say, okay, this person came in and, bashed, curled down a URL, tarred a file, zipped it up and shredded the bash history. So obviously this looks malicious. And in the event, when this happens, we were fortunate enough to take that capture file that allows us to do that deep forensics. So I switch over to captures and I have a capture file that was triggered because this incident occurred. And now, if you're familiar with the Watershark, ways of doing a TCP dump of your network packets in a PCAP file, this will be kind of very similar to you and an enjoyable experience because you have the same concept of doing this with containers in an SCAP file format. So what you're seeing here is Sysdig Inspect, which is an open source tool again for investigation. And you have these nice tiles that help you interact with the data that we're collecting. So when this terminal shell happened, we collected about 65,000 system calls in about 30 seconds. And you can see here, now I can say, what files were accessed, what commands were run, and so on. So this kind of gives me a way to quickly understand specific, use cases, actually drill down into that time period, and actually do very deep forensics, right? And this is very helpful because you can see, again, all the commands that were run, what happened when this terminal shell occurred, and actually see if you can dive deeper into this. But see, there's a way to basically go in, get access to the folder, get access to the file, and now I can actually go all the way down to the payloads of the file if there's data in this one. This one doesn't exist, but essentially you would see, all basically when a rootkit was installed, payload, the actual payload of the file and what the contents of the file was in the event of a terminal shell that occurred. And that's very powerful when you're seeing this from an investigation standpoint, especially when your Kubernetes might kill that container in a matter of minutes or hours, but you have a full audit log of exactly what happened right from this standpoint.
Yeah, that Wireshark style approach has got to be really good because you said 65,000 syscalls, good luck trying to sift through that. But if you can parse that down to say, sure, here's the terminal shell, here's the netcat, those are the easy ones. But more so, here's a syscall that's actually trying to write to disk. And we know this is supposed to be a stateless, immutable image. There should be no disk writing. So that has got to be a great appeal.
Absolutely.
I think, Matt, you were going to say something too.
Yeah, I was just going to say, I mean, you've got the great capabilities that you had in PCAP now available inside the container to see all this additional activity, which I think is great. I assume this data is valuable to two primary teams, right? I mean, obviously the SecOps team who's doing maybe the forensics, but from a performance perspective, the DevOps team who's also managing the infrastructure can also leverage a lot of this data to help with overall performance of their environment.
Absolutely, exactly. So, if you start, and that's really where we see us being, sitting right in the middle of those two teams, right? And really helping them collaborate, because a lot of times you may see performance spikes on your cluster or your specific pod, and then identify that, hey, there was, a denial of service or some sort of other attack that happened that resulted in that performance anomaly or spike, right? So that helps them understand, okay, which specific environment did this happen in? What kind of attack was it that's affecting my application and ultimately my end user experience?
Right. The power of pulling all that data.
Absolutely, and this is what we're seeing, right? Is that as customers get on this cloud native transformation journey, they're seeing impediments from an operational perspective that's really slowing down their development, and that impediments are primarily from all our security, our operations use cases or challenges, but really boils down to visibility into each element of their life cycle, whether it's scanning and seeing visibility into their vulnerabilities, whether it's ensuring visibility at runtime and seeing what's happening at the syscall level, or even visibility into what happens when an incident occurs, and having that forensics capability to audit and respond are those challenges, and solving that across the container lifecycle is really our mission.
Quick question there. Having access to all the data is fantastic, as you were saying, for that forensic aspect, but it can also get a little bit overwhelming, and not to mention expensive, depending on your storage and retention model and where you're putting it. Are there some good strategies that people can use so that they don't get overwhelmed by the data, and just more bits is not always necessarily a good thing, or it's at very least just going to be more difficult and unwieldy, or it's going to be more expensive. So what are some smart ways someone could approach that?
Yeah, absolutely. So a couple ways to answer that question. So one is, one smart thing and kind of unique thing that we have done is really this capability of what we call service vision, which allows you to see your environment from multiple lenses. And this is a way to sort of help you understand the plethora of data that we're collecting, right? So you can say, look, if you're going back to this image, vulnerability use case, I can now say, show me all my images from a host and containers view, or show me this data from a AWS view that I only care about, or show me this data from a Kubernetes view, right, an application owner view. So it really depends on who's interacting with this data, and we customize it and automatically bring that and surface it to the right level. So that way they're not overwhelmed by the amount of data, but actually seeing it in context, right? Now I can say, okay, I only care about this specific application, whether it's a scanning or a risk posture, whether it's a performance data, whether it's a security incident, right? We give them the ability to see this and scope it. And that's one way to get to the signal from all this noise. And the other one is just, the way we're built is, a single agent per host, which allows us to scale, right? So we're collecting all this data without doing a lot of any invasive instrumentation and are just reading syscalls, right, in a non-blocking way. So that helps us have no impact on performance and really, scale as customers scale with these deployments.
Very cool.
Very good.
Awesome. So yeah, any more questions as to how we're seeing the space evolve, or how we're addressing some of the security and monitoring challenges, across each step of the way, I would be happy to answer that.
Cool.
I mean,
Any final? Go ahead.
I mean, I have a pretty good handle on this, right? I mean, having been in the space for a while, that's why I kind of, I like Sysdig and what they're doing. I like the performance side of data you're collecting, marrying that with some of the security data. I think that's a really unique position that the other container security companies haven't done yet. I knew there was an opportunity to do it. You guys are actually doing it. I think that's pretty cool. And look, visibility is the starting point. You cannot get this data the same way you used to without opening other security holes, like giving up root privileges in the container and some other stuff, right? So, these are things that are going to continue to evolve in the market space. It'll be interesting to see how tools get adopted as, containers and microservices and this whole DevOps movement keeps going.
Yeah, absolutely. And I think those are, it's a brave new world, as I like to call it. We'll see how the space evolves, but I think our approach and our ability to do this in a way that's transparent, helps the customer, is really what our mission is.
That's awesome. Well, thanks for that. Thanks for the overview, and thanks for that walkthrough of Sysdig Secure, Pawan. That was really cool to see.
Yeah, absolutely. Thank you so much for having me. This has been great.
Cool. And speaking of plethoras and plethoras of data, I want to thank my two amigos, Matt and John. And if you'd like to find out more, check out securityweekly.com/Sysdig. And also, we hope that you'll stick with us for the next segment. We're going to share some interviews from Black Hat with White Source and Vanafi. But thank you for joining us in this segment. Thank you again, Matt and John. Thanks again, Pawan. And we'll see you all next week on Application Security Weekly.